Hello, today we'll discuss about derivative test. The derivative test helps to find the maxima and minima of any function. There are two types of test. One is known as first order derivative test and the second one is known as second order derivative test. So let's start with this. So first we'll discuss about first order derivative. So to start with this, first we need to define the function. So there will be a function within an interval, say I. The function must be continuous and at point C, which is known as critical point, at that point the first order derivative must be equal to 0. Then we can go for the test. So if the first order derivative change its sign from positive to negative, sign changes from positive to negative, then at point C there will be maxima. And in second case, if the f dash x, the first order derivative, changes its sign from negative to positive, then there will be the minima. At f of C there will be minima. So sign changes from positive to negative, you will have a maxima, and sign changes from negative to positive, you have minima. But it may happen it's not changing its sign, so that there will be no maxima, no minima. So this will be considered as point of inflection. So graphically how we can represent it? Now see the graph where along this axis we are plotting the function and along this axis we are plotting the input x. Now in the first case, at point A, the slope is changing from positive to negative. Here you can see it's a positive slope in this side and a negative slope in this side. So obviously point A gives you the maximum. Now see the point B. Now here the slope is decreasing, so it's a negative slope over there, and here you have a positive slope. So at that point you have the minima. So the second condition satisfied in case of minima. And the third one, what it says, that here slope is not changing, it's a flat region, the slope is not changing. So in this case, this point will be considered as point of inflection. So graphically this is the representation of first order derivative test. But the problem is, every time you cannot get the values just before C and just after C, just after the critical values, before and after the critical values. So there is another way to find the maximas and minima. The second procedure is known as second order derivative. Again, for this test we need to consider a function within a certain interval I. Function must be continuous, and then we are going to check it. So at point C, how are you going to check this one? So first you need to find the first derivative. This must be equal to 0. And if the second order derivative is less than 0 at point C, then this will be considered as local maximum. And the second one, first order derivative is 0 and the second order derivative is greater than 0. So then this will be considered as local minima. And obviously the third one, if both are 0, the test will fail. So there will be no maxima, no minima at that point. So here, just repeating this one, to find the maxima minima, you have to get first order derivative which is equal to 0, which is similar as first order derivative test. And here the additional thing you have to do, you have to find the second order derivative. Now after second order derivative, whether this is less than 0 or greater than 0, it will define whether this will be maxima or minima in the system. Now next, the properties of maxima and minima. So now fx, the function, is continuous within its domain. So there will be at least one maxima or one minima must lie within that range. There must be one maxima or minima. The maxima minima varies continuously or alternatively. So there may be maxima first, then there will be minima, or there will be minima first, there will be maxima. Alternatively, this will be available. Now the third case, if x tends to plus infinite, then at f of x there will be minima, at least one minima. Now if x tends to minus infinite, there must be a maximum value. Okay, so we are assuming a interval a and b. Within that there will be a critical value of c. It's say this is a, this is b, the values of x. Okay, so x, a and b, and that at that point you have the critical value. So at that point, if this is plus infinite, so you will get a minima over there, and the function is negative infinite, so this will get a maximum over there. Now we'll take a simple example to discuss about the idea of maxima, minima, or sometimes it's called the turning point of a function. So we have taken a function, say y is equal to fx, this is equal to 4x cube plus 12x square plus 12x plus 10. Now how going to find this thing? So obviously you don't have the values just before critical point, just after critical point. So first order derivative test is not possible here. So what we can do, we're going to go for second order derivative test. So how are we going to do this thing? So at first we're going to find the first order derivative. So we're going to differentiate the function with respect to x. So it becomes 12x square plus 24x plus 12, and this must be equal to 0. So first order derivative must be equal to 0. So when you are making it equal to 0, so after simple factorization, we'll get the values of x. So if x gives the values minus 1 and minus of 1/3. Now we have two critical values. In one case, x is equal to minus 1, and another case, x is equal to minus 1/3. So we need to check it, the second order derivative for both the points, minus 1 and minus 1/3. So first order derivative. Then we will go for the second order derivative test. So what we have to do? Again we have to differentiate it again, the second order form, and then we need to put the values of minus 1 and minus 1/3. Let's check it. The second order derivative gives us 24 of x plus 24. Now we need to put the value x is equal to minus 1. We need to check its second order derivative at point minus 1. So what this will give? 24 into minus 1 plus 24. So obviously this is equal to 0. So at that point, this is second order derivative is equal to 0. So there will be no maxima, no minima. So this point is known as point of inflection, or it is known as non-turning point. So obviously at that point the car is a flat region. So there is no turning from any particular point. Now what happens in case of minus 3? Go for the second order derivative. So put the value x is equal to minus 1/3. So put 24 into minus 1/3 plus 24, this is equal to 16. So when you are talking about 16, this is greater than 0. What the second property says? That if second order derivative is greater than 0, so at that point you will get minima. So obviously this is a turning point, but you will have minima. So today we will discuss about the idea about maxima, minima, so mathematical idea about maxima, minima, and the basic idea about derivative test, first order derivative test and second order derivative.